Okay, so the next thing that we have here is exercise 12.3, I suppose. 12.3, which is about the section formula in 3D space. So let's see what we have here. So first of all, you have 2 points. You have 2 points. You want to find the coordinates of the point. You want to find the coordinates of the point which divides the line segment joining the points -2, 3, 5 and 1, -4, 6 in the ratio 2 to 3 internally and externally. So what that means is that basically you're looking for 2 points, dividing the line segment internally and externally in this ratio. So the points that you have are basically these points over here. So you have basically -2, 3, so 1, 2 and 3. This point over here, 5, 1, 2, 3, 4 and 5. This point over here is, let's say, call it point A. And you have another point 1, -4, 1, 2, 3 and 4. And at this point over here, 6 units up, 1, 2, 3, 4, 5 and 6. So you have your points in this orientation. Now if I connect these 2 points together, I'll get this line segment that goes from the second octant to the fourth octant. And you need to, basically this kind of exercise has basically two points to it. So first of all, let me write this as the y-axis and this as the x-axis and this as the z-axis. So first of all, what you want to find over here algebraically is use the section formula to basically find the coordinates of the point that basically divides this line segment either externally or internally in this ratio. That you can do using the algebra pretty easily, using the formula. But then again, you do need to know what that point actually, what the relationship of that point with basically your points and the line segment are, because you want to be able to use this process in the reverse order as well, meaning that, for example, suppose that you're basically thinking about some line segment, for example, in space. That line segment goes from, for example, the second octant to the fourth octant, and then you are in need of some point, for example, somewhere over here in the second octant, that, for example, divides this line segment externally in some ratio, and the point has to be over here in the second octant and not over here in the third in the fourth octant, and so on and so forth. Or you want the line to the point to be, for example, somewhere between A and B, dividing AB internally in some ratio. So you need to understand what this external and internal and the ratio and the whole thing really means in terms of where the point is going to be located in 3D space. So what that means is that now, so let's solve the first part of the problem, and then I'll show you how you can make sense of basically the whole situation. So your points are basically, you're looking for the coordinates of the point which divides the line segment joining these 2 points A and B in this ratio 2 to 3. So first you're looking for the coordinates of the point dividing the line segment. Let me write it this way, I don't want to write unnecessarily words. The line segment AB in the ratio 2 to 3 internally, let's say internally. So what that means is that if your line is, for example, like this, and this is A, for example, and this is B, if this is A and this is B, then internally in the ratio 2 to 3, if I take that point to be, for example, point C, if I take that point to be point C, if that point is dividing this line segment internally in the ratio 2 to 3, what that means is that AC to BC, is supposed to be 2 to 3, meaning that your point is going to be located somewhere over here. For example, in the ratio 2 to 3 would be AC to BC. If this point is C, AC to BC is 2 to 3 would be, for example, something over here. I mean, at the end of the day, BC is going to be basically, if you can take the reciprocal of this, that would be BC to AC is equal to 3 to 2, and multiply by AC, you will get BC is equal to, for example, 3 halves AC. That means that BC is 1.5 times AC. So 1.5 times AC would be some distance over here, although BC has to be a little bit smaller here. But you get the idea. Now let's find the coordinates of this point, and I will make a screenshot of this over here. So let's suppose that you want to find the coordinates of this point. So what you need to do is basically use the formula that we used for the internal division of a line. And that formula was basically, if the point is C, then the coordinates of the point C are going to be basically, so over here the ratio is m to n, and internal division, so then you have m times, for example, x2 plus n times x1 over m plus n, and then you have m times y2 plus n times y1 over m plus n, and then you have m times z2 plus n times z1 over m plus n. That is the formula that you use for the internal division of a line through some point, by some point. So now you know what your M is, you know what your N is, and you know what your points are. Since I'm talking about the line segment AB and not BA, I take this point as point 1 and this as point 2. Okay? So then the coordinates of the point C would be basically, you can write it this way, meaning that you see over here you have M times X2, N times X1, M times Y2, N times Y1, M times Z2, N times Z1. So Mn, 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 and so on and so forth. So I can write my M over here, which is basically 2 times some other number plus N, which is 3, times some other number. And then over here I can write M plus N, which is equal to 5. The Y coordinate of the point is again 2 times something plus 3 times something over the same denominator. And the third part is again the same thing, 2 times something plus 3 times something over 5. So now once you have this, then you only need to substitute x2, x1, y2, y1, z2, z1. So x2, x1 would be 1, negative 2, 1, negative 2, and then you have y2, y1, which is negative 4 and 3, negative 4 and 3, and then you have 6 and 5. So if you calculate this, what you will get is basically 2 plus negative 6, 2 plus negative 6 over 5, and then you have negative 8 plus 9 over 5, and then you have 12 plus 15. There has to be something wrong here. Six and 15. Okay. I think there is something wrong in here. 12 plus 15 over 5. Okay, so let me see. So now what you have over here is basically negative 6 plus 2 is negative 4/5. And over here you have 1/5, and over here you have 27/5. Seems to be the right point. Now if I go over here, 12.3, negative 4/5, 1/5, 27/5. Okay, so the point is right. The point is actually negative 4/5, 1/5, and 27/5. So negative 4/5 would be basically this point over here. Negative 4/5 would be this point over here, and then 1/5 would be some point over here, and then 27/5 would be 5 and 2/5. So from here I have to go up 1, 2, 3, 4, and 5 and 2/5. The point would be somewhere over here. That is your point C. But of course, well, I can suppose that when my units are not really perfect, so I'm going to just assume that the point is right over here. 1, 2, 3, 4, 5, and 2/5. I'm just going to assume that the point is over here because the point has to be actually on the line. And what we assumed over there was that the point C was supposed to be somewhere closer to the point A. Closer to the point A. Now, sometimes the coordinate system that you draw in this manner, it actually lies to you. So you need to be careful about that. Meaning that, let me do this in another coordinates, and I'm basically taking this whole time to explain this thing because it's actually something that needs to be understood. You see over here, if I enter the point C as, for example, if I delete this thing, these are the 2 points that we have, point A and point B. And if I enter point C over here, which is basically negative 4/5 and 1/5 and 27/5, then you would see that the point C is actually going to be very close to, I mean, much closer to A than closer to B. And that's basically where the point is actually is. It is somewhere in the second octant. And that's basically where your point C is. So basically you need to understand well, basically what, when you calculate something, where the point is going to end up with, of course, with respect to the other points and the line segments that you already have in your three-dimensional space. So that is that. Now the second part of the question is a little bit more complicated, because it is external division of the line by a point. And so let's do that as well and see what we get. So now the second part of the question is, there is some point C dividing the line segment AB externally in the ratio 2 to 3. The ratio 2 to 3. So what that means is that if your line segment is, now this is something that you do need to understand. And what that means is that when we talked about the external division of a line, we said that if, suppose that you have this line segment AB over here, and we want to find out the point lying on the extended line AB outside of the segment AB, such that AC to BC is equal to 3 to 1. AC to BC is equal to 3 to 1. And if you have this exact situation over here, we will say that C externally divides AB in the ratio 3 to 1. And all of these basically orders are important, meaning that if you say C externally divides AB is different from it would be different from than if you said, for example, C externally divides BA. That would be a different situation, and your point C would end up on the other side of the line segment, much closer to A, and then the left side of A basically. So these are important. So what it means is that C externally divides, we will say that C externally divides AB in the ratio 3 to 1. Okay. So now let's first understand this situation exactly, and then we will go and solve this problem. So the situation is something like this. You have this line segment AB. You have this point over here C. And we say that in this situation, we say that C divides AB externally in the ratio basically 3 to 1. And what that means is that AC to BC what that means is that AC to BC is equal to 3 to 1. That means that AC is 3 times BC, meaning that if I divide by BC, I will get AC is equal to 3 times BC. So that means that this distance BC, AC is 3 times this distance BC. And of course, and then the other way around, if you have this situation over here, meaning that if you have the same line segment AB, so if you have the same A and B over here, and if you have the point C over here, and if BC to AC is equal to 3 to 1, we say that C divides AB, C divides BA externally in the ratio 3 to 1. That means that BC to AC is equal to 3 to 1. So hopefully you have understood these two situations, and then if you understand these two situations, then you can, based on these two situations, you can understand everything else. But it's important to understand these two situations exactly. So now what that means is that I will go over here, and since basically my line segment over here is, for example, is something like B and A over here. So when I say point B divides AB externally in the ratio 2 to 3, what that means is that C is going to end up either here or over here. Okay, now that's what we will find out. But what that means is that basically AC to BC, based on the situations that we just talked about, AC to BC is equal to 2 to 3. Is equal to 2 to 3, which means that AC is equal to 2/3 BC. So if AC is supposed to be 2/3 BC, then C has to be on this side of the point AB, of the point A, which means that C basically ends up somewhere over here. And now AC is basically 2/3 BC. It has to be a little bit, like, for example, 2/3 BC would be this distance. This would be, for example, the point C, and AC, this distance right now is basically 2/3 BC. Now, before I solve this problem, I will go over here and take a look at the solution. The solution for this point, for this point, exact point, is -8, 17, 3. And if I -8, 17, 3. If I put the point over here, -8, this point is -8, 17, 3. And as you can see, is a little bit different from what we discussed. It is a little bit different from what we discussed. And that's basically what I've been trying to find out here, which we will make sense of right now. So if I draw a line segment between A and B over here, remove this. I'm going to delete this and put a point over here, -8, -8, -8, 17, comma 3. The point is over here. I'm going to do a segment over here. So you can see that the point is actually over here. And over here I said that AC is supposed to be 2/3 BC, which is, well, not the case really. Meaning that definition, or basically the conclusion that we have made from that definition, has some problem. So over here, if I calculate the distance between AC and BC, I go over here and measure the distance, between these 2 points AC and BC. It's 15.36, and again the distance between these 2 points is 23.04. And what that means is that basically what I have found out here is that in such situations where your ratio is less than 1, so you see that this actually did not work out. This was not right. And I did have the same problem before. So I just wanted to make sure that it really didn't work out. So what I have found is that in such situations where your ratio is less than 1, for example 2/3 or for example 2/5 or so on and so forth, something like less than 1. So what you need to do is that basically you take your point A, your point A is over here, your point B is over here, and we say that the point C divides AB externally in the ratio 2:3. So normally what I would say is that, for example, AC to BC is equal to 2:3, which means that AC is equal to 2/3 BC. AC is equal to 2/3 BC. And, well, I think this is actually the right thing, meaning that right now what I got over here was the line segment was something like this, and I got these points over here as, for example, C, and AC was 15.36. This distance was 15.36, and BC was 23.04. BC was 23.04. If I substitute these values in this equation, I will get AC is equal to 15.36 is equal to 2/3 BC, which is basically 23.04. And if I use a calculator to calculate this, what I will get is basically 2/3 times 23.04 is equal to actually 15.36. So it is the exact same situation, meaning that when you say the point C is dividing the line segment AB externally in the ratio 2:3, again, since you're talking about A becomes 0.1. You take the distance of the point A, or the point 1, from the point that is basically dividing your line segment, which would be AC, and put that that in the numerator. Then you take the distance between the second point on the line segment, and the point which is dividing your line segment, which is C, so which would be BC, and that would be equal to your exact ratio, irrespective of the fact that whether your ratio is some value less than 1 or greater than 1. So this works all the time. And now, since you can see that AC to BC is 2 to 3, that means that AC is actually 2/3 the distance of BC. So that means that C has to be on the other side of the line segment. So then C is located over here. Otherwise, if the ratio was some value greater than 1, then C would be located on the other side of the line segment. That's how it works. Now, as far as the calculation is concerned, we can of course do the calculation. That would not be a problem, but understanding how this thing actually works is important, and that's how you can make sense of the whole situation. Okay, so now as far as the calculation is concerned, what you can do is that basically the original formula that we had for the division of a line by a point was basically, if I take the coordinates of the point to be C, the formula was m times, and if the ratio is m to n, for example, if the 2 points are x1, let me write them over here. So if the ratio is m to n, if the points are, for example, let's say A is x1, y1, z1, and if the point B is, for example, x2, y2, z2, and if the coordinates of your point are going to be the coordinates of the point dividing this line segment internally would be basically, if I call the point, for example, C, the coordinates of the point C would be m times x2 plus n times x1 over m plus n. The y coordinate would be basically m times y2 plus n times y1 over m plus n. And the z coordinate would be m times z2 plus n times z1 over m plus n. Okay. Now, if the point is dividing the same line segment in the same ratio, but externally, we said that we had to substitute every n with negative n, and so the formula becomes C is the same thing as the coordinates of C are m times x2 minus n times x1 over m minus n. The y coordinate is m times y2 minus n times y1 over m minus n, and the z coordinate would be m times z2 minus n times z1 over m minus n. So that is the formula that you want to use here in the case of this situation. So I'm going to basically erase all of these things, and then what I'm going to write is basically the coordinates of the point. The coordinates of the point C are basically m times x2 or m times x2, which is, so again, you can do the same thing. You can put your m over here and some other number, and you have a negative sign over here and n over here, and divide by m minus n. So your m is basically 2, your n is equal to 3. So 2 and 3, and here you have basically 2 minus 3, which is equal to -1. That is your x coordinate. Your y coordinate, again, you have the same story. And over here you have 2 and 3. The z coordinate, again, you have a -1 over here. A 2 times something minus 3 times something, and that is that. And that is that. So what that means is that basically now over here you need x2 minus x1. So again, x2 and x1 is depending basically which point you take as point 1 and which point you take as x2, meaning that your point A is basically -2, 3, 5, and the point B is basically this point over here. Now I need to, one of these points would be in this formula would be regarded as x1, y1, and z1, that I will just simply call point 1, and one of the points will be regarded as x2, y2, and z2, that I will simply regard as point 2. Now which point you regard as point 1 and which point to regard as point 2 depends on this, basically this instruction over here, that either you take from someone or you give to yourself to solve a problem. When you say the point C is dividing the line segment AB, since A comes first, you take the point A as you take the point A as point 1 and take point B as point 2. And what I'm saying here is going to fit with everything else that I've told you, at least in this video, about these about the division of a line segment either externally or internally, and whether basically the ratio is less than 1 or greater than 1 doesn't really matter. You basically, if you do the same thing, you will get the right result, basically, depending, and it's dependent upon the way that the formula has been derived and developed. So then what that means is that I'm going to take this point as point A and this point as point B. That means that this point becomes point 1 and this point becomes point 2. And so now I can over here I can write x2 and x1, so 1 and -2, 1 and -2, y2, y1, -4, -4, +3, and z2, z1, so 6 and 5, 6 and 5. And so basically then you can simplify this, meaning that you can write this as basically 2 minus -6 over -1, comma -8 minus 9 over -1, comma 12 minus 15 over -1, which is the same thing as basically 2 plus 6 is equal to 8. 8 divided by -1 is -8. Is -2 plus 6 equal to, so that's -8, comma -17, so that's a 17, and -3, so that's a +3. So that's -8, 7, and 3, which is some point over here, which is going to be the point that we were looking for. So now if you have understood everything that I said in these 40 minutes here, that means that you have understood the division of a line segment externally or internally by a point in some ratio. That's basically the whole story here. Now of course we have a couple more examples here. We will go through them and we will of course verify what we said over here through those examples as well. And so now let's go to the second example number 2, which is some other example that we will do as well. So it says that given that P, Q, and R are collinear, given that P, Q, and R are collinear, find the ratio in which Q divides PR. Find the ratio in which Q divides PR. And the points that we have are P is basically 3, 2, -4, and Q is 5, 4, -6, 5, 4, -6, and R is basically 9, 8, -10. 9, 8, -10. Now, in order to solve this problem, so first let's do a simple diagram and see what this problem is all about. So you have basically your x goes all the way up to -10. And I'm sorry, that's actually z. But let's start from here. If this is your y-axis and this is your x-axis and this is your z-axis, then 3, 2, -4 is basically 1, 2, and 3. 2 would be this point over here, and -4 would be 1, 2, 3, and 4. So this point would be point P, which is somewhere in the 1, 2, 3, 4, and the 5th octant, basically. Somewhere in the 5th octant down there. Now, this is point P. The point Q is 5. So 1, 2, 3, 4, 5. 4. So 1, 2, 3, and 4. This point over here, and -6, which is 1, 2, 3, 4, 5, and 6. This point over here is Q. Let me erase this thing. So this point over here is P. And then R is 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. 8. So 1, 2, 3, 4, 5, 6, 7, and 8. -10. -10 is basically this point over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This point over here. And this point is R. Now you want to find the ratio in which Q divides PR. So PR is basically this line segment over here. PR is this line segment over here, and Q is dividing the line segment PR internally in some ratio. So the point Q is basically this point over here. This is the point Q. So now, in order to figure that out, what you need to do is just use the formula. Use the formula for the section formula for internal division, and basically you know that the internal division is basically the coordinates of the point Q would be equal to basically point, basically if I take PR as the line segment, then the point P would be basically point 1, for example. The point R would be point 2, and the ratio it would be M to N, for example. And of course you can take that as K to 1 or 1 to K as well, but I don't think it's really necessary here. So let's see. For example, the coordinates of the point Q would be M times X, M times X2 plus N times X1. It's internal division. N times X1 over M plus N, and M times Y2 plus N times Y1 over M plus N, and M times Z2 plus N times Z1 over 1 over M plus N. These are the coordinates of the point Q. Now you know that the coordinates of the point Q are 5, 4, negative 6. 5, 4, negative 6 is equal to basically, now you can write M times X2. So I can write my M over here and X2 over here plus N times basically X1 over here, and over here I can write M plus N. Again over here I can write the same thing, M times some number plus N times some number over M plus N. And over here I can write M times something plus N times something is equal to M plus N. And here it's X2 plus X1. Now we said that this is point 2, this is point 1. So this is X2, this is X1. So 9 and 3. 9 and 3. Over here you have Y2, Y1. So 8 and 2. 8 and 2, and over here you have Z2, Z1, so negative 10, negative 4. Negative 10, negative 4. So I can simplify this as 5, 4, negative 6 is equal to basically 9M plus 3N over M plus N, comma 8M plus 2N over M plus N, comma negative 10M minus 4M over M plus N. And so what that means is that, for example, you can write 5 is equal to basically 9M plus 3N over M plus N, and then you can call this equation number 1, and then you can write 4 is equal to this equation over here, 8M plus 2N over M plus N. That would be equation number 2. So now if you simplify the two equations, you will get, of course you don't need to simplify both of them. You can just really solve one of these equations. Since it's a ratio, you will be able to get that. Meaning that, for example, if you use equation number 1, what you will get is cross multiply 5M plus 5N is equal to 9M plus 3N. And take everything to one side, 5M plus 5N minus 9M minus 3N is equal to 0. Now 5M minus 9M is equal to negative 4M. 5N minus 3N is equal to plus 2N is equal to 0. And then if I divide by 2N, I'll get negative 4M by 2N plus 1 is equal to 0. And then over here I have a 2, so negative 2 times M by N plus 1 is equal to 0. And negative 2 times M by N is equal to negative 1. Cancel these two out. and then you will get m by n is equal to 1 divided by 2, which means that m is equal to 1 and n is equal to 2. So m by n is equal to 1 to 2. M by n is equal to 1 to 2. So that means that m by n is equal to 1 to 2. And it does make sense. Of course, you should not trust what you see over here, because sometimes it lies to you. But it does make sense, because you see that this distance QR is actually 2 times this distance PQ. So that is basically that. Question number 2, 1 to 2. It's, of course, the concept is not rocket science. It's easy, but of course, you need to understand it, and understanding the concept takes quite a bit of time. You need to do different things and see how things work out, and so on and so forth. But of course, when you understand it, it's nothing complicated. Okay, so the next question that we have is another question. Find the ratio in which the YZ plane divides the line segment formed by joining these 2 points. So you want to find the ratio. Find the ratio in which the YZ plane divides the line segment, divides the line segment formed by joining the points, -2, 4, 7 and 3, -5, 8. So we had a similar question in the exercises as well, in the examples as well, but the question didn't make any sense, although they even had found some answer, which sometimes it's even possible. I mean, in mathematics, sometimes it's even possible to get some answer, but basically the question can make no sense, but then nevertheless you would get an answer. So that's what had happened in the examples, meaning that there was basically some points over here, some point over here, and there was this was the x-axis, and this was the y-axis, and this was the z-axis. And the 2 points, there were basically 2 such points. One of them was in the first octant. One of them was in the first octant. The other one was in the 5th octant, meaning that one of them was up here in the front. One of them was down here in the front. And when you join those 2 points, of course, they have nothing to do with the YZ plane at all. Meaning that the YZ plane is just this vertical plane, which is a vertical plane, which is well, you can imagine that the YZ plane is actually the plane that you're looking through. If you imagine that you're looking through your screen, that is the YZ plane. So I didn't understand that question, and of course I didn't do it over here in these videos. But let's see if these points actually, the line segment joining these 2 points actually go through the YZ plane. So basically the x-coordinate of this point is -2, and 4 over here, 1, 2, 3, and 4. So you have this point over here, and well, 1, 2, 3, 4, 5, 6, and 7. You would get a point over here. Let's call it point A and point B. And point B would be this point over here, 3. 1, 2, 3, -5. So 1, 2, 3, 4, and 5. So it would be this point over here. And then +8. Well, this does go through the XZ, the YZ plane. So 1, 2, 3, 4, 5, 6, 7, and 8. This point over here is point B. Now you can see that if I connect these points together, point A and point B over here, I can connect the 2 points over here, and of course one of the points is back there, and the other point is in the 4th octant in the front, and so the line actually does go through the YZ plane. So this actually does make sense. Now the way that you can solve this problem is that you need to find the point of intersection. Actually, you could find the point of intersection of the YZ plane and this line, and then if you had the coordinates of that line, then you could use the section formula to find out in what ratio basically that point was. That point, you could find out in what ratio that point was basically dividing this line. Now there is one more way to solve this problem, and you could simply use you could directly use the section formula, meaning that you can say that suppose the line, that the point of intersection, suppose the point of intersection of the YZ plane and the line segment AB is point C. It's point C with coordinates, for example, x, y, z. So since therefore basically point C could be written as basically 0, y, z, because on the YZ plane the x coordinate is 0. The x coordinate is 0. So now I can use the 0 over here to find m and n basically. So now if I write the coordinates of a point, now the coordinates of a point dividing a line segment internally in the ratio m to n are the coordinates of a point dividing a line segment internally in the ratio m to n are, so if I call the point, for example, C, that would be basically m times x2 plus n times x1 over m plus n. Then you have m times y2 plus n times y1 over m plus n, and m times z2 plus n times z1 over m plus n. Now, in the case of, now over here, since I'm talking about the line segment AB, the line segment, so now the point C, basically the point of intersection of the YZ plane, and the line segment AB. So now the point C, which is the point of intersection of the YZ plane and the line segment AB, divides the line segment AB in the ratio m to n. So we have basically I take A as point 1 and B as point 2. So over here, point A would be negative 2 comma 4 comma 7. A would be negative 2 comma 4 comma 7, and point B would be 3 comma negative 5 comma positive 8. Okay, so now the point C divides the line segment AB in the ratio m to n. So this is the point 1, this is the point 2, and using this formula I can write that, and then we said that the coordinates of the point C could be written as 0 times comma x comma y is equal to basically m times x2, which is 3, plus n times x1 is negative 2 over m plus n. And then you have another coordinate here, another coordinate here, and that would be the coordinates of the point C. Now it's enough to have this part over here because you can basically, based on this equation, you can write 0 is equal to 3m minus 2n over m plus n. Now if this fraction is equal to 0, that means that 3m minus 2n is equal to 0. That means that, which means that basically divide by negative 2m, you will get 3m over negative 2m, and plus 1 is equal to 0. If I divide negative 2m by negative 2m, I'll get positive 1. So that means that 3m by negative 2m is equal to negative 1. If I simplify these two, I will get, this is negative 2n actually. This is negative 2n. So this means that 3 by 2 times m to n is equal to 1, which means that m to n is equal to 1 divided by 3 by 2, which is 2 to 3. That means that m to n is equal to 2 to 3. So the ratio is basically 2 to 3. So question number 3 is 2 to 3. That's basically that. So I'll end this video here, and then we will continue with, we have 2 more questions here that we will do in the next video. I'll see you in the next video.